Alright, you guys, so let's take a look at another round of problems here. And again, what we're going to be doing is without a calculator, right, figuring some stuff out. And so in the next stanza, we got to really put our thinking caps on. So in the next problem, they're telling us if you're given that the fact that my theta lies between 180 degrees and 270, so that's just buzzword that I'm sitting in quad 3. So right now I have an angle sitting in quadrant 3. It's greater than 180 but less than 270, and I have to determine the sine of each one of the following functions. What's the cosine of that theta over 2? What's the sine of double that angle? And what's the tangent of that angle plus 90? All right, and so what this basically means is under normal circumstances, right now, right, cosine of theta, my argument or my input is just the angle itself, and that angle is sitting in quad 3. But what we're doing is we're making a new function, right? Kind of a transformation, if you would, right? Where the input is being manipulated. I'm dividing it by 2. So all we have to do really is take our relationship that we currently have, and what I'm doing, right, is I'm no longer dealing with an input of theta, I'm dealing with an input of theta over 2. So I'll just come here and I'll divide that by 2. Of course, what's the golden rule of mathematics? Well, whatever you do to one thing, you've got to do it to everybody else. So if this is my relationship I have here, if I decide to divide theta by 2, that means I got to divide everybody by 2, right? And so we now get that 90 degrees is less than theta over 2, which is less than, I think that's going to be 135 degrees, if I'm not mistaken. And where's 90 and 135, right? Well, that's definitely, if you want to draw a picture, here's 90 degrees, and there's 135. So our angle is basically somewhere in that little stretch. But it's definitely in quad number 2. So what do we know about quad 2? Well, in this quadrant, my x is negative and my r is positive. So that must mean that the cosine, right, by definition is x over r. We have a negative divided by a positive, so this must be a negative. So in that case, the cosine of theta over 2 is negative, less than 0. Okay, so that's how we can analyze that. Take what I have, manipulate it the way it needs to be manipulated, and we get what we want. So what about the next one? Well, again, under normal circumstances, right, we have our input is theta, but what we're doing here is we're taking the theta and we're multiplying it by 2. Of course, that means I got to multiply everybody by 2, right? I got to be in balance. And so what I have here, 2 times 180 is 360 degrees. My 2 theta, 270, let's see, 0, 4 is 540 degrees. So 2 theta, right, that angle is sitting between 360 and 540. Well, if we drew a picture, right, 360 would basically have this come around this way. So it's basically, right, ending, it's here. And then 540, right, well, that means I go 90, which is, all right, and then 90 more. So 540, so here would be 360 degrees, and here would be 540. So basically, we're in quad 1, and we're in quad 2, right? And so that's basically where 2 theta resides, all right, if theta begins in quad number 3. 2 theta will be in quad 1 and quad 2 after we multiply everybody by 2. What do we know about quad 1 and 2? Well, in this quadrant, y is positive, and this quadrant, and y is positive. So what do we know about the sine of 2 theta? Well, it's got to be y over r, a positive over positive, so it has to be positive. So that would have to be positive for the conditions that I got. Last but not least, tangent. Well, again, we begin with what we know, right? Right now what we know is that my angle is sitting there, right, in quad 3 between 180 and 270. I want to add 90 to my angle. Well, to be consistent, I have to add 90 to everybody else. And 180 plus 90 is 270 degrees. My theta plus 90, right? 90 plus 270 is 360. So this basically tells me that my theta plus 90, right, is sitting between 270 degrees and 360. So it's right here in quad number 4. So tangent is y over x, and in this quadrant y is negative, x is positive, So we have a negative divided by a positive. That means that this is less than 0, or it's negative. So that's basically how you can use what we have, right? That information there, that inequality about theta, and then manipulate it with what's new and find out where that new angle's at so that I can determine whether I'm positive or negative using my definition. So it's all about where's my angle located at. Where's my angle? If I can find my angle, I know what x and y are in terms of their positive or negative, and then I can determine the ratio. All right, so let me stay here. The next round, what's happening in this last round here, and then we'll cut off to some new material, is we're going to use the information to determine which quadrant am I in, right? So that's theta there. So what quadrant does the angle theta satisfy for the following conditions? So here, right, we're basically saying that the sine is positive, and here we're saying that the tangent is positive. So where do we know that happens? Well, everybody's positive here and here, right? So quad 1 and quad 1 for that guy, right? Where else is sine positive? Well, we know that's going to be also in quad number 2. All right, so sine's positive there. So there's two locations where sine's positive, quad 1 or quad 2. Where do we know tangent to be positive? Well, everybody was positive here, and then the other one was down here, right? Because x was less than 0 and y was less than 0. So this also occurs in quad 3. So here's where we're at, right? I want an angle theta that makes both of them positive, right? And it turns out that the quadrant that seems to work for both of them to be positive is quad 1. So if sine is positive and tangent is positive, that forces theta to be in quad 1. It can't be in quad 2, because if that was the case, sine would be positive, tangent would be negative. It can't be in quad 3, because that would mean that tangent is positive, but sine would be negative. So we got to do both. We have to satisfy both conditions. In this case, sine and tangent are both positive. Next one, cosine's negative. So where do we know that occurring? Well, cosine's negative in quad 2 and in quad 3. Right? So again, that's because x is less than 0 and x is less than 0 in those two quadrants. Cotangent, right? Where's cotangent going to be positive? Well, pretty much the same quadrants that tangent is, right? And that was quad 1 and quadrant 3. So when I compare the two, right, our answer has to be that theta is in quad number 3, because that's where both conditions are satisfied. Cosine's negative, cotangent's positive. All right, so hopefully what you're kind of seeing is you're getting the hang of it. We're still using the definition, getting a feel for where I'm located at, given the sign this time, right, of the trig function. Cosecant, where's cosecant negative? Well, again, it's very similar to when is the sine negative. And we know that to happen down here, right, because y is less than 0 and y is less than 0. So this is in quad 3 and quad 4. What about secant? Well, that would be the same thing as cosine being positive. So where's cosine positive? Exactly where x is positive. So that's in quad 1 and quad 4. So putting these two ideas together, the quadrant that's the same for both is quad 4. So theta has to be in quad 4 for that example. So again, no number crunching, no calculator, just good old-fashioned, I'm using the definition, understanding where y and x are positive, and that's helping me with the definition, figuring out where I'm at. Okay, and of course you can make this harder by putting a third quality, and then but I don't think there's any homework problems like that. So that should wrap up this positive and negative idea. Let's move forward and learn even more things that we can do with regard to our trig functions with an x, y, r definition.